Close your eyes for a second. Imagine that suddenly the world just stopped. Not the traffic, not the people, but the ground itself. Imagine if the Earth decided to end its dance. In the blink of an eye, the atmosphere, which is still moving at 1,000 miles per hour, would rip everything off the surface. Cities would be swept away, oceans would turn into global tsunamis, and the very ground beneath you would be torn apart. We rarely notice it, but we're all balancing on the tip of a colossal spinning top, hurtling through the vacuum. Rotation isn't just a detail of astronomy, it's what separates our cosmos from a static, lifeless graveyard. From the DNA in your cells to the galaxies tearing through the infinite, spinning is the only thing keeping gravity in check. But why? What invisible force gave that first push to every atom in the universe? And what would happen if that energy just ran out? Get ready. What you're about to see will change the way you look at every sunset. Welcome to my lab, Curiosity Protocol Online. To understand the cosmos, we need to head to an ice rink. Have you ever watched a figure skater spin? When they want to go faster, they don't push harder, they just pull their arms in. In physics, we call this the conservation of angular momentum. Imagine that billions of years ago, the solar system was just a giant, lazy cloud of gas. It had tiny, random movements caused by nearby exploding stars. When gravity caused that cloud to collapse to form the sun, it pulled its arms in. That slow movement turned into a fierce rotation. That's why almost all the planets spin in the same direction. But Venus decided to do things differently. While the rest of the system follows the flow, Venus spins the opposite way. It's the only planet where the sun rises in the west and sets in the east. The cause of this behavior is still a scientific mystery. One hypothesis points to a colossal collision in the past. Another suggests that the slow, extreme effect of its thick atmosphere may have braked and reversed its rotation over billions of years. Uranus also breaks the mold, but in a different way. It doesn't spin backward, it spins on its side. Tilted at nearly 98 degrees, Uranus looks like it's rolling through space, as if it were knocked over during the early days of the solar system. But why is spinning so important? In space, there is no friction to slow the planets down. Rotation generates what we call centrifugal force. Think about it. The sun's gravity is a hungry monster that wants to swallow the Earth. If we were standing still, we'd fall to a fiery death in just a few months. What saves us is that we're moving sideways so fast that we miss the sun constantly. And this spin is so powerful that it actually alters time. As the Earth rotates, it warps the fabric of space around it. This means time passes at slightly different rates depending on your altitude. Without compensating for this time warp, your GPS would miss your location by miles every single day. Spinning is the balance between life and annihilation. When things spin to the extreme, reality gets weird. Meet pulsars. These are the cores of dead stars, the size of a city, but with the mass of the sun. They spin so fast, some more than 700 times per second, that they emit beams of radiation like cosmic lighthouses. The sound of these stars spinning is like a frantic heartbeat of the universe. And above them, we have Kerr black holes. They spin so fast, they drag space-time itself along with them. Imagine dipping a spoon into a jar of honey and spinning it. The honey sticks to the spoon and swirls with it. In these places, the rotation creates the ergosphere, where it's impossible to stand still, no matter how powerful your engine is. It's an endless whirlpool. But here is the biggest mystery. If everything inside the universe spins, does the universe itself spin? Scientists looked at the oldest light in time, the cosmic microwave background, searching for signs of global rotation. And the answer, so far, is no. The universe seems to be a steady stage for everything inside it to dance. We live in an eternal choreography. Without the spin, time would have no cycles, planets would have no days, and the cosmos would be nothing but a free fall into the dark. The next time you feel the breeze of a new day, remember, you're on a spaceship spinning through the vacuum, kept alive by the memory of a push that happened 13 billion years ago. If this journey through the gears of the cosmos expanded your mind, leave a like and subscribe to the channel. Your journey for knowledge is just beginning. Now, I want to hear from you. If you could travel anywhere in space, would you choose the center of a spinning galaxy or the event horizon of a black hole? Let me know in the comments. Thanks for flying with us today. See you at the next access point, somewhere in space-time.